Welcome back, Algebra 1 students. Today we are in lesson 38. And we're going to talk about something called ratios. Now, many times you guys have seen a ratio written something like this, with a semicolon between the two. And that's all well and good in language or, printed on something as a reference. But when we use a ratio in math, we are going to write it like a fraction. And that literally means for every 3, there's 4. 3 to 4, or 3 per 4. So we say that we have written the fraction 3/4 when we see that, but it's actually, all fractions are actually ratios. An equation or statement in which two ratios are set equal is called a proportion. So we could say that 15/20 is a proportion to 3/4 because we know that if we multiply 3 times 5, we get 15. And if we multiply 4 times 5, we get 20. So in this instance, we have what's called a scale factor of 5 because we multiplied both sides we multiplied this side by 5 to get this side. We increased this side by 5 to get this proportion here. We could also divide this side by 5 to get the original ratio. And that's typically why we write a ratio as a fraction, because we can recognize its reducibility, I guess, pretty readily, or much more readily than if we write it side by side. The math just seems to make more sense when we do it as a fraction, and it's easier to calculate when we treat it like a fraction. So we could solve proportions that contain an unknown by setting the cross products equal and then dividing to complete the solution. For instance, if we had a ratio of 7 to 5 something, and we knew that 7 to 5, the 7 number equaled 91, we could find out what the 5 number was by doing a cross multiplication. So 7 times x would be 7x, and 5 times 91 would be 455, right? Then we would divide both sides just by 7, just like we would normally do with any other equation, and then we would have x is equal to 65. Okay? So let's try one. Let's try this proportion here. This is 38.1. And we are given 4/m. We don't know what m is. And 21/5. We don't know what those numbers are yet. So we're going to cross multiply. And when you cross multiply, typically you want to keep the numerator over its side. So 4 times 5 is 20. And 21 times m is 21m. Now when we divide both sides by 21, we find that 20/21 is equal to m. We can't reduce this anymore because the factors of 20, there's no factor of 20 that is also a factor of 21. So it just stays like this, and this is the correct answer. Let's try some more. I want to introduce you to the grid method. 38.2. Let me write this out for you. All right, so here's the problem. The ratio of pigs to goats in the barnyard was 7 to 5. If there were 91 pigs, how many goats were there? So this is the grid method that I was taught, and it works really well. What you're going to do is you're going to create a little grid, and you're going to create a side for the ratio and then a side for the actual number. And then you're going to list what you have on the ratio. So we have pigs and we have goats. Now the ratio of pigs to goats in the barnyard was 7-5. Whatever order they put the words in, that's the order the numbers are in. So pigs is first, so 7 is pigs. And then goats must be 5. Now they tell us there were 91 pigs, so the actual number of pigs was 91. How many goats were there? So now we have to figure out how many goats. That's what we're looking for. That's our unknown. So that's going to be where we put x. So we just take these numbers and write them just like they are, equal to one another, 91 over x, because we don't know how many goats there were. So x is our unknown value for goats, the actual number of goats. So now all we do is cross multiply. 7 times x is 7x. And 5 times 91 is 455. And again, we divide these by 7 so we can find x, and x is 65. So there were 65 goats, and that is the number that we found for the unknown x. All right, and that is correct. All right, so now let's look at 38.3. And I'm going to write that for you. And here's our problem. In the same barnyard, the ratio of chickens to ducks was 9-4. If there were 108 chickens, how many ducks were there? So let's set up our grid. We have the ratio and we have the actual number. And we have chickens and we have ducks. And the ratio of chickens to ducks was 9-4. And there were 108 actual chickens, and we don't know how many ducks. So we just take this and set this up in exactly the same order. We put 108 over x because we don't know what x is. So 9 times x is 9x. And 4 times 108 is going to be 432. So we divide both sides by 9. And we find that x, the number of ducks, is going to equal 48. So now we know we have 48 ducks. All right, it's pretty easy when you think about it. You just make your little chart and transfer the numbers over, put the x where you have a blank, where you can't solve it. Now these will get a little bit more difficult as we go along. Your grid might get bigger. That's okay. As long as you put things in the right spot, the grid will tell you how to set up your problem. So that is all I have for lesson 38, and I will see you in lesson 39.